Okay, today we are going to talk about let's see here, 2.5, negative color, 2.5. We are going to talk about optimization problems. So basically, these are what, as I said in my announcements, are affectionately called word problems, right? And strikes fear in the heart of many when they hear that we are going to be doing word problems. But as business people or business majors, we should care about when are we going to be using this stuff, right? So I want to kind of talk about some of the steps maybe to approach a word problem like this, and then I want to do two examples for you, and that should take us probably about a good 20 minutes. So the steps for solving a word problem. These are just kind of some of the basic steps. So, I think you probably remember in high school when they were like, read the problem, read it again, read it a third time. So of course you want to read the problem. I hope that's pretty obvious that we should read the problem. But there are some steps that we can take here. So one step might be to draw a picture if necessary. So I'm going to do two examples for you today where one time it's not necessary to draw a picture, but another time it is. So, if possible, if we're dealing with something that's geometric, we might want to draw a picture and see, what is going on. So another thing here, number two, okay, draw a picture if necessary. If that's not necessary, that's okay. What we want, number two, this is a big one. Determine what is to be maximized or minimized. Depending on the situation, what do we want to find the maximum or the minimum of? Minimized. There we go. Oh, spelling. Okay, so this is kind of a big deal right here, right? We want to determine what is it that we actually want to find the maximum or the minimum of. Okay, so I'm going to just call this, this will be I think your book calls it Q. This will be my equation. Q equals blah, blah, blah. What do we want to find the maximum or minimum of? And I want this to be an equation, which we'll figure out, here in the next two steps. So number three, we need to assign variables. What are we dealing with? Are we dealing with the number of toys sold? Are we dealing with the cost of something? What are we dealing with here? Are we dealing with the length of a fence? Which that's one we're going to do today. So assign variables. And then what do we do with those variables? We determine or write. We want to write an equation for those variables. So we want some way, and so that's going to be this Q guy right here. We want some way to relate those variables. That's going to be one of the equation that's going to relate that variable. So this equation here relates to this 2 right here, okay? We want to know what is it that we need to maximize or minimize, and we want a function or an equation that is going to do that for us. And then 5, what we want to figure out here is determine constraint equations. So if I want to ask you, what are the dimensions of a rectangular garden that yields the largest area? Well, I have to give you some sort of constraint, right? Or else we'd have infinity by infinity. That'd be the largest rectangular garden we could have. I have to give you some constraint, like maybe the amount of fencing we have, the amount of money we can spend on fencing. So those are what we mean by the constraints, okay? So determine constraints, all right? Let's see, determines constraints that relates to that relate the variables together. Unless we are so if we're given the function itself and we just need to find the max and min, then we don't need to worry about this number 5. Sometimes our constraints can just be what the value is, like x has to be positive if we're talking about, the number of products that we're going to make or something or produced. If needed, so if I get a constraint, if you do get this constraint, usually this constraint so let's say, Q involves an x and a y. Well, it's hard to maximize a function that involves 2 variables. So we'll maybe have another constraint equation that involves an x and a y. I'm just going to put x comma y. So what we're going to do with that constraint equation gives us a way to relate the variables. So our number 6 here is if needed, okay? If you have this constraint equation in 5, if needed, write Q, which is the guy that I want to maximize or minimize, in terms of one variable. Because if I want to find the maximum or the minimum of this function, I need it to be just in terms of one variable so that I can take the derivative and do everything we just did in 2.3. And then number 7, use the first or second derivative test, either one. Whoa. To find max and mins. That's what we mean by maximizing find. Sorry about that. Find, you get it. That's what we mean then. That's what we mean then by determine what is to be maximized or minimized. So maximizing or minimizing a function is using the first and second derivative test to actually find the maximum or find the minimum of that function. And then finally, I'm going to make you do this. I hated this when I was a math student. I hated it. As a teacher now, though, what this does for me, when you state the answer in a sentence, what that does for me is that helps me know that you actually understand what's going on. A lot of times I'll get students that know what the answer is, but they don't actually understand what that answer means. So when I have you state the answer in a sentence, that will help me know what you understand, basically. Okay, so I want to do 2 of these for you. I'm going to do these 2 for you in this lecture, and then if I need to do some more later, I sure can do that. But I'm going to do these 2. Remember to look at the fun sheets. That also will give you some examples of what you can do. And for purposes of time, I just went ahead and typed this out so I don't have to write this all, and this is going to be my first example. So I would pause the video right now, I would copy this example into your notes, and then start it up again. Okay, so here's our first example. Our first example is, it is estimated that the cost of constructing an office building that is X floors high is given by this function right here in thousands of dollars. How many floors should the building have in order to minimize cost? So here's what I would like you to do. What I want us to do here, so if we look back at, my goodness, if we look back at our first layer here, draw a picture if necessary. Well, that's not necessary. I mean, if you want to draw a picture of a building with some floors, maybe just to, pass the time, go for it. But look at number 2 here, determine what is to be maximized or minimized. So the nice thing about this first one is that we don't really have to do too much in terms of the first 6 steps, okay? So what I like to do is when I do these word problems, so you should try and do these word problems the way I am showing you how to do this. I like to state what I want and then any constraints. So what do we want here? Wouldn't it be simple? Wouldn't that be nice in life if I could just write down what I want and then it would come true? I want to minimize, or I want the minimum cost, right? I want the minimum of this cost function right here. So I'm just going to rewrite it. I'm given the function. That's nice. What are our constraints here? Well, I mean, I guess hypothetically, the only constraint we really have is that x must be greater than or equal to 0. I could graph this and I could maybe see, is there any other reason x needs to be constrained? But what is x again, right? X equals the number of floors. So it wouldn't make sense to have negative floors, and I guess you could say, well, Sarah, it doesn't make sense to have 197 floors or whatever, wherever we're at, or have 1,000,000 floors, and I understand that, but we'll be able to find our minimum, okay, with our constraint just being greater than or equal to 0. Okay, and I know this has a minimum because I know this is a parabola opening up. All right, so let's go back to to our steps here. So draw a picture if necessary. We didn't have to worry about that. We determine what is to be maximized or minimized. We know what our variable is. We've determined an equation because it was given to us. That's pretty nice. The constraints, really all we have is that x must be greater than 0. So number 6 I don't need. So look at that. We're all the way down to number 7. So here's what number 7 says. Actually, use the first or the second derivative test. Now what I want to do is I actually want to minimize this function and I want to find the minimum, which is what you did in 2.3. So how are we going to do this? Well, let's just do a quick first derivative test. I think sometimes the second derivative test is nice. I'm a little partial to the second derivative test myself, but let's just do the first derivative test, because what do I need to do first? Well, because it's called the first derivative test, you probably need to take the first derivative. Remember, I need to find my, set this equal to 0 to find my critical numbers. So we get 4x is equal to 48. So what is my possible critical number here? 12. Remember what x is standing for. It's standing for the number of floors. So it looks to me, we only have one critical number. It looks to me like this is going to be our winner. But here's what I need to see you do. You must show me that you know that's a minimum. Now here's how you can show me you know it's a minimum. You can take the second derivative, plug it into the second derivative, and show me that it's a minimum. Or how with the first derivative test, what do? We just make a quick number line. Oh, wow, that should, I'm going to try and let that be an actual line. Quick number line with the 12 here. I'm going to plug this into C primed. If I take a number less than 12, let's say 0, and plug it in here, I get negative 48, so that's negative, so my function's decreasing. If I get a number bigger than 12, let's say 100, I always just pick something huge, I would have 400 minus 48, which clearly is positive, so this is going up, so thus we have a minimum. I need to see this part. You need to show me that you know it's a minimum or a maximum, or else you will not get full credit for the problem on the exam or on your homework. I need to see that you have shown that it's a minimum. But this is good, right? We knew we wanted to get a minimum. We wanted to minimize this function. So because we have found that minimum, we've proven it's a minimum, now we're ready to state our answer. So let's go back and see what this says. How many floors should the building have in order to minimize costs? So one thing that I want you to think about here. So on chapter or 2.3, right, we would say we have a local min. If I were to ask you to write this, you would say of, and you would take C of 12 and get some number, right, and plug that in, and you would find the cost. So please understand that the cost is the actual minimum value. Where does it occur when x is 12? What is this question asking? How many floors should the building have in order to minimize costs? So what is it asking for? Is it asking for x, or is it asking for the cost to build x floors? Well, it's asking for how many floors. So I don't need the cost, so all I need is the x value. So I don't even need to go through this step because it's not asking me what is the actual minimum cost. So my final answer, again, look at how many floors should the building have in order to minimize cost. We'll put the building should have 12 floors in order to minimize cost. And now with this sentence, I am not asking you for Shakespeare, I'm not asking you for prose, I'm not asking you for a novel. I'm just asking you for a sentence. I think sentences involve like verbs and nouns, right? I'm asking you for a sentence that just tells me you understand what this problem is asking. The building should have 12 floors to minimize cost. I hope that makes sense. I want to do one more because these can be a little bit tricky. Okay, so let me clear this out. And here's my next one. This one is always just a good time. Okay, so our next example. Our next example is one where we can draw a picture. So copy this in your notes. Pause this video if you need to and then come back. So a homeowner has $320 for fencing around the rectangular garden. 3 sides will be constructed with wire costing $2 per linear foot. The 4th will be constructed with wood costing $6 per foot. Find the dimensions of the area of the largest garden that can be constructed with 320 feet of fencing. Blah, 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 right? What does that even mean? All right, let's go back and look at this. Now I think we should draw a picture. I'm going to draw a picture. I'm going to determine what is to be maximized or minimized, and then I'm going to assign variables, and then I'm going to determine an equation. So let's go back to this. So I have a rectangular garden. So listen, don't overthink this, people. You should just draw a rectangle. So, and you should, if you're the teacher and you are drawing this, you should try and use the tools that are at your disposal. So, a rectangular garden. Ooh, look at that. I just love this little, I'm so excited I found this little trick. Oh man, that's just beautiful. I wish I had that on the whiteboard when I teach in class. Here's my rectangular garden. Okay, what do we want? What do we want? We want the maximum area, right? Look at this. Find the dimensions of the area of the largest garden. So what do I want to maximize? I want to maximize area. Let's assign variables. Now, I'm going to let this be x. I'm getting a little crazy here. Actually, I don't want to get too crazy. I'm going to let this be y just because it's up and down, and it doesn't matter. This is going to be x. This is a rectangular garden, right? I don't know the dimensions. Look at what this is asking. Find the dimensions. So that's kind of a hint that that's my unknown. My unknown are my dimensions. So I'm going to let x be this distance right here, this linear distance. I'm going to let y be this distance right here. So I want the maximum area. Sorry, my email keeps coming up. I want the maximum area. And what is my equation that relates my two variables? That's the area of a rectangle, okay? The area of a rectangle is just base times height or length times width. All right, and what is my constraint? So here's where this problem is a little tricky. So what is my constraint here? Well, my constraint is that I only have $320 for fencing. Okay, and 3 of the sides will be constructed with wire, costing $2 per linear foot, and the 4th will be constructed with wood. So here's what I'm going to do. I'm going to say that this side here, okay, this side here, let's say, and this side here are all wire. Doesn't matter. I just know one side is going to be wire, and I know the other side is going to, I'm picking another color here, going to be wood, right? So I'm going to let the pink be wire, and I'm going to let the yellow be wood. So here is what my constraint equation will be. How much money then is this going to cost? So let's look at the wire, right? So wire is $2 per linear foot. So I know that this side right here will cost me $2 times y. That's the length of this side. What is this side here going to cost me? $2 times x. That's the length of that side. $2 per foot. This side here is going to cost me $2 per foot here. And now what about the wood? How much does the wood cost? $6 per foot. So this side right here is going to cost me 6. Ooh, that should be an x. That is a crazy x, people. So all I've done here is I've determined how much this is going to cost. So this guy, 2y. This guy, 2x, because these are wires. This guy, 2y. This is all wire, right? And then this guy here is going to be 6x. Look at that distance. That's x. And if I add those all up together, that's money, people. This is all talking money, your business people. That should be 320 bucks. That's all I got. And I'm going to just simplify a little bit. So that tells me that 8x plus 4y equals 320. That can be sometimes the hardest part about these, is figuring out that constraint equation. Okay? All right. That was fun. I enjoy doing these. Let's go back and look and see what step we're on. Okay, so we drew a picture, we determined what was to be maximized or minimized. That was our area. We assigned variables, we determined an equation. Man, we are knocking this out of the park. Number 5, we determined the constraints. Let's look at, we are at number 6 now. If needed, write Q in terms of one variable. And that is what we're going to do right now. Look at this guy. I want to maximize area, but the problem is I can't maximize this if it's in terms of 2 variables. So what I need to do is I have this constraint equation that relates x and y together. So I'm going to solve this for y. The reason I solve for y is because I know I'm going to have to divide by 4. So I can divide each term by 4, and that shouldn't be so hard, right? I'm going to get out my calculator just because I don't trust myself doing arithmetic. Oh, that was easy. Oh, Sarah, can't believe you did that. I don't trust myself doing arithmetic on a video here. So all I did here was solve for y. So if I solve this guy for y, that shows me that y is equal to 80 minus 2x. So what I'm going to do to that is I'm going to put that in for y right there. So now I'm ready to do either the first or the second derivative test. So let's go ahead and do the first derivative test. So I haven't taken the derivative yet. All I'm doing right now is I'm rewriting this so that I have just one variable. So a equals, notice I'm not putting a derivative symbol because I have not actually taken the derivative yet. Okay, now I'm ready to get going on this. Now we're ready to have some fun. I know you're thinking, but Sarah, I've been having so much fun already. Is it possible to have more fun? Oh, it is. It is. So I'm going to take the derivative. That's 80 minus 4x. Just like we've done before, I'm going to set this equal to 0. What does that imply that my critical number is? Well, if I subtract 80 and divide by -4, that tells me that x would equal 20. I'm going to check and make sure that that actually does give me, what am I trying to do? Dimensions of the largest garden. I need to make sure that that gives me a maximum. So I'm going to plug this into a primed. If I put 0 into here, I get 80, which is a positive number, which means I'm increasing. This is looking good. If I plug in 100 in here, just a number bigger than 20, I would get 80 minus 400. I don't know what that is, but that's negative. I mean, I do. I know what that is. That's a negative 320. All right, so positive, then negative. So what does that mean? That sure enough, I have a maximum, which is what we wanted. So what does this tell you? This tells you that if you let your dimensions, I want this side to be 20 feet. Remember that because that's my x. I want this side to be 20 feet, right? And now all I need to do is solve for y. But look at, isn't this great? I have y already in terms of x. So I'm just going to do y equals 80 minus 2 times 20. And I can do that. What that tells me is that the dimensions that will yield the largest area with the constraint of the money I have for fencing, and 3 sides must be wire and 1 side must be wood, the dimensions that will yield the largest area is a 20-foot by 40-foot rectangular garden. Okay, and I would write that out as a sentence. So the dimensions, oh, my handwriting is going to get bad down here, yielding, is that how you spell yielding? I think so. The largest area. I don't have anyone here telling me it's not. R, and usually when we do dimensions of something that's rectangular, think about a room that you have in your house. Oh, that's a 10 by 15 square foot, whatever. So the dimensions are 20 by 40 feet. And that's my answer because it just asked for the dimensions. Now, if it actually asked what is the largest area, I would just take 20 times 40 and that would give me the largest area. These word problems can be hard, and I get that. So you need to contact me and let me know if you have questions about this stuff. Word problems are not super intuitive. Pretty much in mathematics, the way you get good at it is by doing it. So you need to do the suggested problems, you need to do the fun sheet, you need to do the required problems to get good at this stuff. And as always, please, please, please let me know if you have any questions.